So we have a problem in which water is flowing into each of the bottles below. So we've got these three bottles here. And the water is flowing at a steady rate, meaning that it's constant. Okay. We have to match each bottle shape with the graph of the height of the water as a function of time. So again, the water is being filled in at a constant rate. You can think about it like being filled in like as if you were filling up your bathtub or filling up a tank with a garden hose. Okay. Now, as we fill the water in, so let's say we look at the first one. As we fill the water in, there's all this volume, all this space down here. And so as the time goes on, this might be 1 second. At 2 seconds, we would expect more height than this because we have less volume to fill than we did down here. So if you notice down here, this volume, okay, is larger than the volume up here. So if the rate is constant, we would expect the height to be a little bit higher, right? Because this volume has to be the same as this volume. And of course, since our sides are pushing in, the only place for the water to go is up. And so on the next one, we would expect even more height because again, we've got less volume on the sides, and so the water's got to go somewhere and it'll go up. So it looks like the height should be increasing at a faster and faster rate and constant all the way through. So if we look at, we want one of these in which the height is growing faster and faster, and so that is C, because notice at, let's say, t equals 1, our height is maybe at 1. Okay, so let's say this is a height of 1, 2, 3, 4, 5, 6. Okay, just like that. So at 1, we should be at a height of 1. Okay, at time 2, at the second time we look, we're at a height of 1, 2, 3. Okay. And at a height, or excuse me, at a time of 3, we'll be at a height of 1, 2, 3, 4, 5, 6. And that's up here. So notice that we have this nice increase. Okay. Okay, now let's take a look at the second container. So on this container, we've got a very small amount of space at the bottom. So we would expect as we start filling it, that at first, the height increase would be significant. And as we go up, the levels between the heights would be less and less until we hit here, and then of course we'd fill up a little bit faster. So we should see a quick increase in the height, and then that should drop off. Okay, so our initial increase, right, our initial height would be, this increase would be very quick, and then it would steady off, the height wouldn't change very much, and then the height would change again very quickly at the end. That's one possibility, right? So it looks like this is going to be our guess for B. So we thought this was A. We think this is B. Now let's look at C. Well, C, we're going to expect the height to change, not too much down here, but then it's going to change very quickly as we go through this center part. I didn't draw that too well, but at first it's going to be small, and then it'll be larger. Okay, and then it'll be smaller again. So it'll increase. The heights will increase at a less and less pace, or less and less quickly here, right? So we've got a quick increase, okay, and it's going to steady off. So steady, increases quickly, then slows down again. So this is going to be our C value. So we've got A, B, and C.